Hello, we're happy to welcome you at Cloud4U, enterprise cloud provider, founded in 2009. Today we'll talk about load balancer settings. To begin with, let me remind you what exactly a load balancer is. It is an entity which distributes external requests to a pool of servers by monitoring the state of individual servers in the pool, i.e., not just randomly distributing requests, but according to certain rules. It is necessary to distribute the load across multiple servers and thus avoid overloading the server with requests in order to ensure high availability of service. There are certain products like this, which are quite common, but today we will talk about load balancer, which is a built-in part in edge gateway of our cloud infrastructure. So here is the load balancer tab. Let's move to the beginning and get started. Our task is as follows. We won't consider load balancing for the website, we'll consider a more specific application. Load balancing between two RDP servers, i.e. we have clients connecting from outside and they should be redirected on one of the RDP servers, which will handle their connection. There are a few settings on the first page. Here you can enable load balancer, enable its acceleration, enable logging, and select the logging level. We don't need it all at the moment, but it might be useful for you to set, for example, level debug. Note that as soon as you change something, you'll get a warning message that there are unsaved settings. If you need to change something, don't forget to click Save Changes. Well, click Cancel because we already have a load balancer pre-configured. Go to the next tab, Application Profiles. There may be several different services on the load balancer. For example, if we have several sites, we will need to list the rules for all of them here. We have already created a rule here, and I will just demonstrate it to you now. Note, what is marked with a red asterisk are mandatory fields. For example, the type, although not marked with an asterisk, if you don't mark it, nothing will work. In the same way, if I choose here HTTP, I will not be able to connect any certificate either. So in this case, we set the name. Since we have neither HTTP nor HTTPS, you will have to choose between TCP or UDP, except for MSRDP, we won't change anything here. Let's press Keep. Since we already have everything configured, we'll press Discard and get the application profile. Let's move on. As I mentioned above, we want to keep track on the nodes. In other words, we want to monitor them somehow. In this case, we have a ready set of monitors. If we will set up some other service, you may have to create your own monitor. This is not necessary for this task. Then create a pool of servers. That is the pool from which we choose those upon the client's request. Go there. The pool is created, but we've opened it for editing. The name is mandatory field. Also choose an algorithm. In this case, round robin. Pay attention to what we're going to check. We will check with the default TCP monitor, the one I showed you. Then we add the members of this pool here. Let's open some record for editing. These are my test servers, which I have already added here before. If you don't have enough to balance the nodes, you can add more. Here, as you can see, the switch is enabled. This means that if any server is involved in the pool balancing, at the moment should be off, for example for technical maintenance. You can just turn it off so that the customers do not get a failure in service. Do not forget to press Keep, and if it's prompted, don't forget to click Save. After have added the required number of pool members, also click Save. The pool is created. A few words about application rules. You can write some simple rules here and some quite complex ones. Why you need to do that? Since load balancer will work round robin, you can set priorities but not in full. If you want to provide access some node to a client and give the second node only if the first one is unavailable. With the added rule, you can make this sequence work. For the test example, it wasn't necessary, but if you need, you can create them here. Now, let's move on the reasons why you did all this. We have the last tab of the virtual servers, and if we open it for editing, the first and second switch do not interest us. Then we're asked about application profile. If we had not created it, we would now have to close everything and go to the very beginning and do it all. That means you can't type anything in here, you only have to choose. Then the name of the server we choose one in accordance with its assignment and IP address. In this case, this is external IP address, visible from outside your edge gateway, which will be used to receive requests from the outside. Now, we need to select button with which you can choose the address. Thus, you are insured against accidental misprints. We allocated a separate IP address just for the example, but it is not necessary. The only thing that is important is the work of load balancer on the rules of NAT shouldn't overlap, but we'll consider it later. That is, I have this port at another address, which is needed for this example, but it is busy, so we allocated a separate address for the simplicity and convenience. But again, this is not mandatory. Protocols and port are clear. What protocol the virtual server will work with, that is, what it will handle. If we put HTTP or HTTPS, it would receive the appropriate requests. If it doesn't fit these definitions, then leave only TCP or UDP, port 3389. From the client's point of view, it is connected to this IP address. It gets to the RDP server, which receives requests on the standard port. Default pool is the pool with which the server will work. Here you can only select the pool we created earlier. So there are connection limit simultaneous and connection rate limits. Advanced step. Here you can add the rules for this particular server that we mentioned before. We already have everything set up, so I won't save it because we haven't changed anything. To sum it up, we created a virtual server with this external address which receives TCP requests on port 3389 and distributes it to the pool of RDP servers. I.e., the client connects to this address, for example to a remote desktop, and ends up on one of the two nodes. We'll check it now. Now, we again use VDI provided by Cloud4U as a service, and in this case, we use it as a client computer from which we'll connect to the load balancer. We have all prepared and tried to connect to the first node. Here we go. Users can work from here. Now, we will disconnect and in a minute turn off the first node and check what happened. Here we have the cloud control panel, and here is our first node. We are going to shut it down or just stop it. Let's wait for it to shut down. Actually, the existing speed and our default cloud, in this case not the fastest machine and not the fastest storage policy, is already shut down. So, here we are back on VDI. Note that we connect to the same external address. As you can see, we successfully connect to the second node. Thus, we conclude that the balancer works, It really distributes requests between the nodes, and when one of the nodes crashes, it monitors its state and redirects to the next working node. Another thing is that there can be more than two nodes. You can also add rules, for example, give preferences to one of the nodes and leave the second one as a backup. That's the result we have achieved. The balancer works. And in conclusion, I would like to add a few words about configuring NAT and the capabilities of this scheme in general. Here are Edge Gateway settings. Pay attention to the first line, the load balancer description. This line is added itself when configuring the balancer. The same way, a line can be added, for example, when configuring VPN. I said before that load balancer requires a necessarily external IP. We just had a busy port. In this case, you see that you're running NAT from this address, and in this case, the standard port. Basically, if you use another port in this field outside, you can use it in this IP. It doesn't affect the balancer. It will work. For example, you can set a DNAT rule on the same address for access directly to individual nodes, not for clients, but for main tenants, for example, administrator nodes. Keep in mind that you can do this. And finally, we have just considered that both nodes are located in one data center, but nothing prevents them from being located in different data centers and not even virtual, but physical. This is a bit more complicated to compare it to the one we have just discussed, but allows a maximum fault tolerance, i.e., even a physical data center is shut down, although this is very rare. If you use two physical data centers, the load balancer, in this case you need two of them because they should be located in different DCs. Even a complete shutdown of one of them will not lead to unavailability of the service. They will connect to a certain domain name and reach one of the pool servers. Of course, you will have several servers and user must be registered on all of them as a local user, or, which is more correct, using Active Directory. Then you won't have any problems like that. That's all we wanted to say about load balancer. See you soon.